This is a video from section 4.1. A critical number of a function f is a number c in the domain of the function such that f prime of c is equal to 0. So in other words, the slope of the tangent line at x equals c must be horizontal, or f prime of c doesn't exist. So f isn't even differentiable at x equals c. And so, pictorially, if you have a function f, right? And so this is c, and I look at this point up here on the graph, notice how the slope of the tangent line is equal to 0. And so you're going to set the derivative of the function equal to 0 and solve for x. So I want that c that makes the slope 0, the slope of the tangent line 0, in other words. And so f prime of c doesn't exist. So in other words, I have something like this. The classic example is like a sharp point. And so this is a situation at x equals c. The slope of the tangent line doesn't even exist. And with that in mind, we're going to look at some examples. So what we're going to do is we're going to find the critical numbers of the function. So it's really important that you guys take this step by step. So let's go ahead and take a look at example 1. Suppose I had g of v equals v cubed minus 12v plus 4. So the first step, find g prime of v. Well, g prime of v is going to be 3v squared minus 12. Second, now I don't have to worry about any undefined values because I'm not dividing by 0. I'm not taking the square root of a negative number, things of that nature, right? So I don't have to worry about where g prime of v is undefined. So I'm going to take g prime of v and set it equal to 0. So 3v squared minus 12 is equal to 0. Now, if you guys don't mind, can I say v squared is equal to 4? And so solving for v, I get v is plus or minus 2. And so the answer here is going to be negative 2 and 2. And that's example 1. Example 2. Suppose I had f of x is equal to 2x cubed plus x squared plus 8x. So I'm going to take a look at f prime of x, and that's going to be 6x squared plus 2x plus 8. Now, I'm going to set f prime of x equal to 0. So 6x squared plus 2x plus 8 is equal to 0. Now, what I want you to do is I want you to divide everything by 2. And so 3x squared plus 3x squared plus x plus 4 is equal to 0. Now, a is equal to 3, b is equal to 1, and c is equal to 4. The discriminant, if you guys remember, it's a really quick way to look. So this is b squared minus 4ac. But that's 1 minus 4 times 3 times 4, which is less than 0, right? Now, what does that mean? That means 3x squared plus x plus 4 equals 0 has two complex solutions. And so what does that mean? Therefore, f has no critical numbers. And that's how you do the second example. So let's take a look at example 3. Suppose I give you p of x is equal to x squared plus 2 divided by 2x minus 1. So we're going to get a little more complicated. Now, in a situation like this, we want to apply the quotient rule. Okay, now we're going to take the bottom function, which is 2x minus 1, and I'm going to multiply by the derivative of the top function, which is 2x. And I'm going to take the top function, which is x squared plus 2, and I'm going to multiply by the derivative of the bottom function, which is 2, and I'm going to divide by 2x minus 1 to the second power. Now this is where it's very important as compared to chapter 3 that we got to be able to simplify. So p prime of x, so we get 2x minus 1 to the second on the bottom, right? Now on the top, we get 4x squared minus 2x minus 2x squared minus 4. Just like this. And so this is equal to 2x squared minus 2x minus 4 divided by 2x minus 1 to the second power. All right, I'm going to factor out a 2 from the numerator. And I get x squared minus x minus 2 divided by 2x minus 1 to the second. We have to be careful because I want you to note something. Yes, f prime of x is undefined at x equal a half. I agree. Okay, but x equal a half is not in the domain of f. Okay, because if we go back, right, the original function is x squared plus 2 over 2x minus 1. So x equal half can't happen. And so what that means is x equal a half cannot be a critical number. And now, set p prime of x equal to 0. And so that implies 2 times x squared minus x minus 2 is 0. And so therefore, 2 times x minus 2 times x plus 1 is equal to 0. And then what that implies is x equals 2 or x equals negative 1. And so what that says is that 2 and negative 1 are critical numbers of the function f. or in this case, function p. So let's write p. And this was example 3. So let's do one more example for this video. We'll call this example 4. Suppose I had the following. Capital F of x is x to the 3/4 minus 2x to the 1/4. So let's take a look at the derivative. You get 3/4 x to the negative 1/4 minus 1/2 x to the negative 3/4. Okay, so this is tricky, okay? Now, negative 3/4, so 1/4 is less than 3/4, right? And so negative 1/4 is greater than negative 3/4. And so what I'm going to do is I'm going to factor out an x to the negative 3/4. In fact, let's factor out an x to the negative 3/4. And you're going to get 3/4 x. Now, the question is, what can I add to negative 3/4 to produce negative 1/4? Well, I claim that's going to be a half. Okay? And then I'm going to subtract 1/2. And so this is 1 over x to the 3/4 times 3/4 x to the 1/2 minus 1/2. So it's very important to be able to factor out that negative exponent. But I just looked at which one was the smaller exponent. And so if you guys can read my handwriting, that should say half. So let me write that a little nicer. Okay. Now, f prime of x is undefined. When x equals 0. And that works because remember, if you go back to the original function, x equals 0 is not in the domain. So that one's okay. Now, f prime of x equals 0 when 3/4 x to the 1/2 minus 1/2 equals 0. So let's go and write that down. Now, multiply through by 4. And so we get 3x to the 1/2 minus 2 equals 0. So x to the 1/2 is 2/3, right? And so I'm going to square both sides. And so by squaring both sides, I say x is 4 over 9. And so therefore, the critical numbers of f are, I'll just say 0 and 4/9. And that'll conclude this video for section 4.1, and it's on finding critical numbers. Thank you.